All right, so 2.2. I'm just going to introduce one or two things first, and then we'll just do a bunch of problems. All right. So the name, which you don't need to know, what is the title anyways? Multiplicative property of equality. The big idea here is you can add, subtract, multiply, or divide the same number on both sides of an equation. And it stays equal. No, I would say it stays true, equal, balanced, whatever words you want to use. Again, everything you say in math is an asterisk, right? You can't multiply, add, subtract, divide by anything. There's one exception.
Zero.
Yeah, can't divide by zero. Can't divide by zero. That doesn't come up that often, but, and I'm not going to show you this thing now, but later on when we're dealing with polynomials, I'll show you. You can actually, if you can divide by zero, you can just show anything is true that's totally not true. There's a classic proof that 1 equals 2 that seemingly absolutely proves that 1 is equal to 2, when obviously it's not. Actually, give you a really simple example. Okay, so, no, we don't have the capabilities yet, because there's a trick you need. Okay, anyways, so that's a big idea. The other big idea here is what's called inverse operations. So inverse operations are pairs of operations that exactly undo one another. AKA cancel each other out. Okay. So the most common two examples that we're going to use are multiplication and division. Well, it's man, I have the hardest time spelling multiplication and division are inverse operations. Right? Here's an example. If I take 72 and I multiply it by some just ungodly number, let's say we multiply it by, 5.178, okay? I don't want to know what that is. I don't want to do that. But then, if we divide by 5.178, what do we get? Right? Everybody in this class could do that in their head. Well, part of it's equal to 1. Do we get?
72.
Yeah, 72. So the multiply by 0.175 divide by 5.175, that part cancels out to create 1. But that inverse operation thing is saying if you multiply by a number and divide by the exact same number, those end up canceling out, and you get that 72 all by itself, right? Add 2, subtract 2, cancels out. Multiply by 10, divide by 10, cancels out. Right? Same thing with addition and subtraction. So addition and subtraction are inverse operations also. So if I start with 10 and then I add 7 and subtract 7, what do I get? 10, right? Because the adding 7 and the subtracting 7 cancel each other out perfectly. Okay, and that's how we solve equations. Is we take an equation that's complex looking with x's and w's and y's and z's everywhere, parentheses and exponents, and we whittle it down bit by bit by subtracting 2 from both sides. You can basically do anything to both sides of the equation as long as you do the same thing to both sides of the equation. Okay. You can double both sides of the equation. If you have 5 equals 5, double it, 10 is for sure equal to 10 because you started with the same numbers and you did the same thing to both sides. So obviously, the same thing to the same thing is the same thing, right? There's no variation possible. So our golden rule is, we can do the same thing to both sides of the equation, and we're gonna cleverly use inverse operations to slowly cancel out layers of this equation and whittle them down until we have x all by itself. Okay, again, if you really wanted to be clear, multiplication and division are inverse operations, except you can't times by 0 and divide by 0, right? 0 always the exception. Okay, anyways, let's do some examples now. There's lots more inverse operations I could list. I mean, if you wanted to, keep the list going, you could say, x squared square rooted are inverse operations. You could say, x, well, let's do 5. Let's do 5 raised to the x power, and then if you take the log base 5 of that. So again, I mean, there's layers and layers and layers that in the future you'll learn all sorts of inverse operations. But the ones we're really going to use are add and subtract, cancel out, multiply and divide, cancel out. Math is full of forwards and backwards. Okay, so here are a couple problems from 2.2. Alright, so it starts with a problem like x over 7 equals 4. Alright, so what could we do to both sides? Yeah.
You can multiply 7.
Yeah, because what's this say right now? Yeah, it says x divided by 7. So you would cleverly do the inverse operation of times by 7. And we know for sure that that cancels out, and we get x equals 4 times 7 is 28. Okay. Again, you can see that from over 1 cross cancel. Okay, things get a little bit harder when you see something like maybe 8 with negative 4y equals 32. So if we just look at the left side, what's the left side of the equation say?
4y.
Multiply by what? So what? Negative 4 times y. So how would we do the inverse operation of that? Yeah, exactly. Not divide by 4. There's no 4 here. Always divide by the entire coefficient. If the coefficient is negative, you divide by a negative. Okay? So we get, y is negative 8. And then things get a little bit harder. People like to get creative with ones like this, and that's okay. Creativity's fine. So 20 is 20 equals negative 5 over 8x. Okay? So yes, you can multiply both sides by negative 5 over 8. But why? Or over 8 over 5. But why? What is happening here? Multiplication. So if we want to solve this, what will we do? Divide by what? Just whatever the coefficient is. Always, doesn't matter. X times something. If we want to get rid of that something, it's really easy. It's just like if it was y times negative 4. We divide it by the coefficient. So if it's x times negative 5/8, we divide by negative 5/8. That's it. So we divide by whatever's here because we're 100% sure, regardless of how scary the number looks, if we multiply by a number and divide by the exact same number, it will always 100% cancel out, except for 0. Okay? So now we see why we could multiply by negative 8 over 5, because that's what we're doing. Divide by negative 5 over 8 is the same as this, right? And then we have equals x, and then you just do some scratch work, and you get this negative 1 and 4 times that. That's 32 over negative 1, negative 32, right? The arithmetic is the less important part. I say that now because we're done with chapter 1. I just assume everybody can do it now, right? That's the less important part. We're focused on chapter 2 now.
So you invert the fraction on that side?
Yeah, because we are dividing. So this was 20 divided by negative 5/8. So we switched it to times and flipped it over to 8 over negative 5. Yeah, but originally the scratch work was we divide both sides by whatever the coefficient is there, regardless of what it is. Okay, and then only later do we see, oh, that's really multiplication. All right, so let's do a more complex problem. Right, that's only in the 20s. This stuff goes up to the 60s. Okay, so now, what if we have something like our first real multiple step equation? So I'm going to tell you how I see this, which is a little different than how other people see it. Don't say it's easy, that's rude. It serves no benefit, it only hurts people.
All right,
it's not
we need to work hard on this.
But the way I see this is, the x is the center thing you want to get at. And if we were to plug something in for x, like 5, what would we do first? Yeah, we would multiply by 2 because that is the first, most tightly held together thing. So in terms of like layers, that's the last thing that you're going to peel off. And then the thing that's so loosely even, really it's not even affecting it. I mean, it's not even in the same term. It's another island far away. And so I see it as kind of peeling off layers to get to that x. And so first, the extra terms that aren't even affecting it, let's get rid of those until we're dealing with our one island. And then let's peel off the last layer and get there. In general, and I'll talk about when we do 2.3 tomorrow, I'll talk about general strategy for solving all linear equations. But the general strategy when you see something like this, we already talked about, is what? Well, it's under 6. Let's do 4. Right, general plan there. First step is
Your variables.
yeah, variables on one side, then
Numbers on the other.
numbers on the other. And then there's only one step. Once you put all the variables on one side and all the numbers on the other, the last step, regardless of how scary the numbers are, is
Software.
yeah, by dividing by, yeah, or general, just whatever number is there, the coefficient there. If it's negative x, what will we divide by?
Negative.
Negative 1. If it's 1/2, what do we divide by? A half, right? Doesn't matter what number's there, just the last step is divide by the coefficient, regardless of decimal, fraction, negative, positive, anything. So it's always variables on one side, numbers on the other, divide by the coefficient. And every linear equation looks like this. The only steps that come before this are distribute, combine like terms, and then every problem in chapter 2 looks like this basically. Okay? Alright, so here, what will we do first? Yeah, why? Because we gotta get what though? So it is plus 5, so we will subtract 5, but what's the big idea, the first step?
The x alone.
Yeah, we gotta get the x's on one side, the numbers on the other, right? We already got all the x's on the left. So the first step is get all the numbers on the right. So minus 5, this cancels, and we get 2x equals 8. And then last step is always divide by the coefficient, regardless of what it is. 5 by 2, 5 by 2. X equals 4. So let's look at one last problem. Let's go about as hard as it can get in 2.2, which would look like, well, our classic problem. So here's the last problem in this section. So 6z minus, wait, let me see if there's one different one. That is, okay, 6z minus 3 equals z plus 2. Okay? So somebody raise your hand. So maybe I haven't heard from yet. Sydney, is that hand up? Or is that just a... Yeah, well, thank you for volunteering with your stretches. Could you help me out? What's the first step?
Subtract 2.
Okay, so we can subtract 2, okay? And again, other people might be like, I would have done it different. That's totally okay. That's correct. Everybody can do it their own way. So she put all the numbers onto the left, which means we're going to put all the variables onto the right, which is totally okay. A lot of people are like, variables have to go on the left, regardless of anything. Okay, so we got 6z, -3 and -2 make -5 equals z. So it's the next step. So yes, Louise, help me out.
After this, you would have to, what do you call it? I would do, get the, wait, should it be there? See, get the 6 over to the other side.
Exactly, so we subtract the 6z and put it on the other side. So z minus 6z is -5z equals -5. And then the last step always is,
Divide.
yeah, divide by -5, because that's the coefficient, not 5, but -5. And so you get z equals 1. It doesn't matter if the z's on the right, if the z's on the left, they're equal. 3 equals 3, then you can switch the blue 3 and put it first, and the red 3 second, it doesn't matter, 3 is equal to 3 regardless. So yeah, z equals 1. Okay. So that's it for today. The rest of the 27 minutes is just going to be time for you to work. I'm never offended.